In this video, I'm going to show you how to use Wolfram Alpha to be able to plot the unit step function, the Heaviside function, and variants of that. So we're going to go to Wolfram Alpha. So you can just Google Wolfram Alpha if you want to. And what you're going to do to plot just any unit step function is go to the extended keyboard. And in Wolfram Alpha, the unit step function is recognized by theta. All right, so I'm going to plug in theta, and you might remember this one, t minus 1, where we just shifted the Heaviside function 1 unit to the right. And we graph it. Right? And notice what it says right here is that assuming that t is a variable, use t minus 1 as a unit instead. But remember, this is going to be our unit step function. It does exactly that. So it produces the graph. All right, so it's 0 until we get to 1, and then up here, it just starts becoming 1. Remember, we had this one. So, and what I'm going to do is I'm just going to say theta t minus 1, and then we had theta of t minus 3. And I'm going to graph that. And you might remember that was the segment from 1 to 3. All right. And this graph just shows you that segment. That doesn't really help much. This is the graph that we're more interested in. All right. If you wanted to change that, I guess the domain, you could say from 1, 3, or even from maybe the domain 0, 4. And that might change the values of it. And so check this out. What it does is it just graphs it from over the domain which you're interested in. It actually will approximate the arc length of a curve, although we're not going to necessarily do that in this course. All right. Remember, another one that we had was sine. So we had sine of t times t minus the unit step function times 3. And what we said that did was it just turned off the function until we got to 3, and then it turned it back on. Okay, and so this is a better picture of what it looks like. Right. Another one that we had was sine of t minus the unit step function until we got to 3 times sine of t. All right, and these are all ones that we graphed in the previous video. And this does almost the converse of what we just graphed, is that it allows the sine function to oscillate until we get to 3 seconds, and then it makes it 0. Right, so hopefully this helps you to be able to work with the unit step function. You could even, if you wanted to, and this is a bit of a precursor to the next video, is you could take the Laplace transform of the unit step function. All right, and we're going to get to this. Right, but it actually gives you what the unit step function t minus 3. In fact, if I was just to make it the unit step function of just t, or the Heaviside, it's 1 over s. And you might be thinking, okay, well, how does that happen? All right, and what we're going to do in the next video is we're both going to verify, and you could probably see what happens if I was to put t plus 2 in here. And that didn't turn out as expected. So let's say t minus 3. All right, there we go. And so this is actually pretty cool that we can go through and now find the Laplace transform of these sorts of things by utilizing this Wolfram Alpha. And what's going to happen is in the next video, I'm going to show you how to get through that. But then also we're going to show you how to be able to find the inverse Laplace transforms. And then why do we want to do this? Well, ultimately we'll show a problem as to the use of the unit step function.